Okay, area of a triangle. So here is the formula for the area of a triangle. First of all, we have A equals 1/2 the base times the height. 1/2 the base times the height. And so why is that formula 1/2 base times height? This being the base. And again, the height is the shortest distance from the top of the figure to the bottom of the figure, forming a right angle between that top and that bottom. So there's your height of your triangle. 1/2 base times height, though. So why is it 1/2 base times height? So if we look at this example off to the right-hand side, and I draw this line right down from diagonal from one corner to the opposite corner. I've created two triangles here, okay? And so the area of this whole parallelogram would be base times height, right? Base times height. So if I did the parallelogram, that would be base times height. But I don't want the whole parallelogram. I don't want all of this area. I just want this half of it, and I don't want this half of it. So when you're finding the area of a triangle, you have to do half of base times height. It's as though when you're looking at this figure over here that there is sort of an imaginary other triangle, okay, forming a parallelogram. So you would have to imagine as though there was this other triangle sort of up here, and they're one half and the other half. So I just want this half. So the area is 1/2 of a parallelogram, 1/2 base times height. All right? So that's why the formula is the way that it is, 1/2 base times height. Sometimes you're going to see it written like this, base times height over 2. So 1/2 of the base times the height, or take the base times the height and divide it by 2. Dividing by 2 is breaking something in half. So those, you'll see those formulas two different ways. All right, so let's look at this example. 5 centimeters, put my right angle in. The hypotenuse is 13 centimeters, and this side over here is 12 centimeters. So if I want the area of that triangle, I'm going to do 1/2 times the base times the height. So 1/2, the base is 12, and the height is 5. So remember, the height is the shortest distance between the top and the bottom. That forms a right angle. So there's your height. So 1/2 of 12, if you do 1/2 times 12, you get 6, and 6 times 5 is 30. So I have 30 centimeters squared is the area of that triangle. All right, let's look at the second example. I have a base of 10 feet. I have this segment and this segment. This piece is 4 feet. So 10 to there, and then 4 to there. Let me fix that. It's really difficult to read. Let me do this instead. This is 10. Okay, and then this is 4. Is that better? Easier to read, I hope. And then we have this segment over here, which is 6.4 feet. Okay, so the question is, how do I solve the problem? Area equals 1/2 times the base times the height. Now here's the question, what's the base? And I get students all the time that tell me the base is 14. The base is not 14. Yes, the distance from one end all the way to the other where the altitude falls is 14, but the actual triangle's base is just that 10-foot section. So area equals 1/2 times 10, and then the height is the altitude, shortest distance from top to bottom, that's right here, so 6.4. So easy way to do this, 1/2 of 10 is 5. 5 times 6.4 is going to give me an area of 32 feet squared. Okay, 32 feet squared. And that is how you find the area of triangles. So let's scroll the page up and work on trapezoids a little bit. Clear the screen. Scroll the page up a tad and work on some trapezoids. All right. So the area of a trapezoid. First, let's look at the characteristics of a trapezoid. This is considered a right trapezoid, or a formal trapezoid. It's a perfect symmetrical trapezoid. They don't always look like this. Sometimes trapezoids look like this one down here, where one side is a right angle or vertical, forms a perpendicular, and the other side is not. So they're not always symmetrical, and you can't always break them in half. So as I'm saying here, sometimes trapezoids are not isosceles. In other words, when you cut it down the middle, this side over here does not equal this side over here. Same thing with this one. When I try to cut it down the center, one side does not equal the other side. Okay? So that doesn't help me. This one, though, if I break it right down the middle, is isosceles. And the reason it's isosceles is because the sides are equal. So these two sides are equal to each other. And of course we have one base higher than the other, or longer than the other. So if my formula for trapezoid is 1/2 the height times base 1 plus base 2. So it's going to be really important that you add these together first. You got to do this part first. So do this part first. Really important that you do the base 1 plus base 2 part first, then multiply times height, then do 1/2. So here's your base 1. That's base 1. And this one is base 2. Base 1 times base 2. We have our height. Let me clear out some of this stuff. Make some room. Okay, so this is base 2. And then here's our height. So shortest distance from top to bottom, that forms a right angle, is the height of the figure. And so if we needed to find the area, we would add the two bases together, the lengths of the two bases, and then we would multiply that times the height, and then we would take half or divide by 2. So again, the examples just beneath the box are just showing you that they're not isosceles. So here's where the height could be found. Or you could do it over here on this side. It doesn't really matter which side you choose to find the height. They're both going to be the same because they're still the shortest distance top to bottom that form right angles. So it doesn't really matter which one you choose to use as the height. In the second example, though, it does matter which one you choose to use. Not necessarily, but typically this is given to you. And it is actually one of the sides, okay? And so your height is right there, given to you usually. All right, so let's take a moment and try a couple of trapezoids and see if we can remember how to use some of our triangles. And so we do have to use what we know about triangles to solve for trapezoids. This is very tricky, can be sometimes quite confusing. So let me show you what I have here on this example. So we have 6 feet on this side. We have 6 feet on this side because I'm going to break it right here into 2 sections. And I'm going to tell you that this is 4 feet. And so these are right angles. And then I'm going to tell you that this is 3 feet. And I'm going to tell you that this is 5 feet. So what I did right there is I broke it into 2 sections. And so oftentimes I get students that will say to me, Ms. Pelletier, can I just find the area of the rectangle and then also just find the area of the triangle and then just add them together? You certainly can do that. It's not always easy to do because you're not always given all of the side lengths so that you're able to do them separately. And so if we just go ahead and look at our 1/2 times the height times base 1 plus base 2. Excuse me. Oh, sorry, tried to cover the microphone. We need to figure out the base. Let's do that. So base 1. Okay, that's base 1. That's a B, sorry. My marker's being really cranky today. And this is going to be base 2. Okay, so let me fix base 1 because that looks really sloppy and we can't even tell what it says. So base 1 is 6 feet. Base 2 is going to be the combination of 6 feet plus the other 3 feet, so 9 feet for base 2. The height of this particular trapezoid, shortest distance top to bottom between the two bases that forms the right angle, is 4 feet. And then I have to multiply all of that by 1/2, or take half of the answer. So 6 plus 9 gives us a total of 15 times 4 times 1/2. And so an easy way to do this is what's 1/2 of 4? That's 2 times 15 gives me an answer of 30 feet squared. So there is your formula for trapezoid and how to pay attention to doing the bases first, adding them together, then multiplying. Let's look at example 1. Example 1. So 8 feet. This is a 60-degree angle. This entire thing is 15 feet. Okay. This is 11 feet. And that is, let me see what's given. I forgot what was given to you. That's it. So that's all you have for information. So we have a little bit of a problem. We have base 1, all good there. We have base 2, all good there. But we don't have the height right here. We're missing the height. Base 1, base 2, but we don't have the height. So how do you find the height? Well, here's the question. Let me put some of the information over here. So here is the triangle that we're dealing with right now, and we know that this segment is 8. I know this is a 60-degree angle, and I know that since my altitude forms the right angle, this is going to be my H. Okay? So here's my problem. What kind of triangle is that? I have to be able to find this height over here. So this is a 90, this is a 60. This must be a 30. I'm going to label that. So this is a 30, 60, 90 triangle. So we have to go back to solving a 30, 60, 90 triangle, special right triangle. So remember, across from your 30 is where you place n. The hypotenuse of a 30, 60, 90 is always equal to 2n. And the third side is equal to n square roots of 3. And so now we have to solve that. We have to figure out what n is so that I can then plug it in. Okay? So let's see if I can do that. I'm going to say that this is the formula I'm going to use to solve, because this one has 2 variables in it and this is just an n, so that's not helpful. So 2n equals 8. To get n by itself, I'm going to divide by 2. n equals 4. So this length is 4. That's helpful. Let's put it over here in our picture. That's 4. And my height, if I plug 4 in, is 4 square roots of 3. Okay? So now I have to say, let's plug this into the formula for trapezoid. So let's see. Because we have the height, we have base 1, we have base 2. So we have everything we need for our formula. 1/2 the height, base 1 plus base 2. Okay, so area equals 1/2. Now listen, I don't want to have to deal with 4 square roots of 3 in my formula here for height. So you're going to take your calculator and you're going to do the square root of 3, and then you're going to multiply it by 4, and you're going to get 6.9. That's what we're going to use in here. Okay, base 1 is 11 plus base 2, which is 15. 11 plus 15, because that's always where I need to start, is 26 times 6.9 times 1/2, or divide it by 2, and you get 89.7 feet squared. Alright, so when you're dealing with trapezoids, you are often going to deal with either a 30-60-90 or a 45-45-90 to find that missing height. Okay? Really, really important that you use that and you're careful. Please ask if you're getting stuck and you're having trouble with those, or you need to review your 30-60-90s.